I'm not sure, Professor, it's going to show my screen. Okay. I'll just present using the or my file first, just in case. I'll just use my file first. Then, if we are going to run tests, I can just switch to my computer because it might not record. Yes. Right. So I'll be presenting my work. So I have two parts for my report. So part one would be the data set that we're using, and part two for uh, the checking of the two sets. So here I used the Python for using the OLS. So okay.
Eyesight is poor, so make it 150 will be enough. Okay, okay, all right.
So here, this is the result from the Python.
Okay,
So the arrangement is just different from eViews, Professor, but I believe that the coefficients t-test, just t, and the p-value would
it's
be
all the same.
yes, Professor.
Okay,
So
let's see.
from here, we can see that there's changes in the sign. So one of them, it's education. It's supposed to be positive, but in the first OLS, it's negative. And the other one is further education, which is supposed to be positive, but it's negative here. The rest of the signs would be just the same. So since there's a sign change, we can see that there could be possible multicollinearity problems. So here. So I did a pairwise correlation analysis. So it shows here, and what's important findings is that if it's going to be about darker colors, we can see right here that they're depending too much on each other. So we can see 0.88 is family income together with MTR. That's a very high correlation to one another that might hint a bit of multicollinearity. Another one is 0.72 MTR with the husband wage. That's another hint of multicollinearity, again with family income. Where else? We can see here 0.89 with husband age together with the age of the the worker.
Okay,
So
just a
yeah,
second.
yes.
Did yours pairwise comparison? Did you do all the 15 variables? Okay, but you didn't find that many with higher than 0.7, right? Just the one pretty close to 0.7. The rest of 2 or 3 is 88, right? Wow, so it's different.
This is Pearson correlation, Professor.
Yeah.
Yeah.
Yeah, Pearson.
Yeah. I just click the command in Python. It just presents them. All of the data set.
Oh, okay, okay. I like to mention, I think this is a good point too, okay? The data I give it to you is 753 sample size, okay? The one Steve working with is the data with only hours greater than 0. So which is 428. So almost 325 dropped from the result which Steve working with. Okay?
Okay.
All right? So that's the difference. That's the difference. Now I wanted to say that, some of we have 300 more hours with hours is 0. And the rest of hours is greater than 0. Okay? Let's think. What's the meaning of the hours 0? She's not in the
Not in the work
labor force in market,
uh-huh.
but all the X variables does that will affect the woman not working in the market?
Mm.
Yeah. Does that X variable also explain she does not work in the market, therefore the hours is 0?
Oh, that can affect.
That can affect, right? But there's another problem is the huge, we have 325, which counts for maybe 40%. 40%, at least 40% of our data is 0. Therefore, working with 753 sample size and working with only 428 sample size means really different. Okay? So for OLS models, okay, for OLS model, if you have huge 0 numbers, and those 0 number make sense, okay, using OLS estimation is not good. We will learn another methods, but this is all cross-sectional data, statistical methods we may not teach in this class.
Mm-hmm.
Okay, since we wanted to more have time series data.
Mm-hmm.
But for business area, we need to concern this one. So we will use another approach to estimate the model with huge of 0 values on our Y variables. But so far, since we didn't learn it, we just use OLS.
Okay.
Okay, so just report what you have done.
Okay.
Okay.
But later I can try to do quickly.
Yeah.
A remedy.
Oh, sure.
Yeah.
Sure.
So this is easy. So so that shows some correlation with each other. So might hint that one of them might be redundant to one another that we could actually drop.
Yeah.
So that would be not husband education, husband wage, family income, MTR, and where's that other one? I think this is still husband age. So those are things that we could consider to drop. Family income. I do the partial correlation analysis for all of the variable. Yes. So I didn't show the exact or all of the values because that's too much, Professor. So what happened is after getting all of the partial correlations, it shows that given that we hold this z, these variables, then these are the variables or the features that change the signs most. So we have age, husband wage, and MTR. MTR is the most here that changed all of the variables for all of the partial correlation. So it shows that this one we might consider in dropping since it might be a confounding variable for the set. Yes. Next would be the yes. Higher is the worst because this is the sign change. So remember when we did with Professor just to when you check the partial correlation and if they change from the original pairwise correlation, that means it might be a redundant or confounding variable or a redundant variable. So MTR changed the most out of all of the tests. So yeah, it shows that from all of them, then MTR would be something a bit suspicious compared to but I can show I can show something here. Yes, it's really long. It took around 20 seconds to run for all of it. I mean, yes. But if you're just running one partial correlation, it's usually just 1 millisecond. Yes. So there's no library or any other function to run all of them. So I just had to make my own. Oh. Next is the auxiliary regression and the VIF analysis. I combined the two since we used auxiliary regression to compute for the VIF. So this is the result. So when we use this regressor that we use as a independent variable, this is the R squared. And then this is the computed VIF. So we can see here, actually my threshold is 4. So I considered husband age, family income, MTR, and there's another one here. Age, actually, are quite suspicious in terms of the multicollinearity problem. So those are the 4 considerations I'm going to look at, as well as those two features earlier, father education, as a somewhat suspicious for the change. So here are some recommendations I tried, because I tried all of them: family income, education, age, MTR, husband wage, and all of them combinations of each, 1, 2, 3, combination of each. It boiled down to these 4: family income, education, age, and MTR. I tried not to drop age, since I think it's really, really important to have the age of the person in the data set, into the predictor. So I just used these. So all of them would reduce the R squared and adjusted R squared. However, the goal I'm looking at is to keep the education, since even though I have family income just to drop and leave the others, we will have higher R squared and adjusted R squared, but the education sign would still be negative, different from our assumption. So my goal is to make the education the same sign as the assumption. So when I drop these 4 combinations, that's the time when the education becomes positive, as we can see here. So here, education is now really low in coefficient, but it's now positive, because if I try the others, it will just become around negative 16, 15, 1. So in this combination, education turns 0.2. So it's a positive now. But again, the R squared is very low. Yeah, the education is high. Yes, very high. Actually, whatever I do.
The sign is correct,
Yes.
but okay.
Yeah, it's still very high, Professor. But
Okay.
I tried to remove education as well. That did not do well with the whole model.
Let me see what the rest of the variables. Okay.
Just these, Professor.
Okay. I would like to mention that kids less than 6 years old, well, and kids greater than 6 years old. I think this, according to the literature review, was in a Western country. I don't think that's in Asia country, because the culture is really different. Okay, those mothers with kids less than 6 years old, compared with greater than 6 years old, less than 6-year-olds is important factors for mothers will join to the labor force market or not, but not the greater than 6 years old. Okay, so in this consideration, we may just keep just only less 6 years old as the variables, and drop the greater than 6 years old, because all this dimension, we really see all these variables. We can separate them with some dimension. So kids less than and greater is 1 dimension, and age and husband's age, husband education or something, can be 1 dimension. So if you keep 1 dimension, 1 important variable, 1 dimension with 1 important variables, I think that's maybe it's good enough. Okay, you see what I'm saying? So if I have the age and also have husband age, then I will keep age and husband's age as 1 dimension. education with husband's education as a dimension, and also education with father and mothers and husbands. I put them 4 variables as a one dimension. Okay, then try to choose the one with most important factor to represent that dimension. I think this is one of the we will say the parsimony. Parsimony means the variables is as simple as possible. The regression X variable is as simple as possible. Okay, I think this is all technique. We have to gradually learn it. Okay.
So this is the example, Professor, the original one I did. So you see here, because we still have greater than 6, you can actually try using it.
Yeah. Oh, you can do it right now. Okay, okay. You're you're the best. So education is
Oh, it's now
uh,
better coefficient.
yeah, and but this one is high.
Still higher.
Yeah. And here we have some like mother's education and father's education. So maybe you can try to remove mother's education too, since that's all parents' education, right? So how it works
It's now better.
is okay. Well, how about marginal tax rate?
I removed that word.
Yeah, I know that.
Did I put it?
Put it back. How it works?
Oh, you cannot put it.
It's already negative, so that is not good. Okay, let me see. Employment, husband's education. This one. But the sign is better, right? Then, did you put the MTR in?
Oh, yes. That's more negative.
Oh, it's become negative.
I think it's because I still have 0.
Yeah, maybe you have. Yeah, maybe the reason. Immediately. Well, usually we put the hours greater than 0 to specify the sample we use, right? H hours greater than 0. Now we should have 428. Yeah, okay. So what's the result now? When we say that those variables we find it from literature, those variables are the borderline, means that cannot be moved out, even it is not significant. So we should have some borderline to start with. If we don't have any borderline to start with, it's just, it's never ending. So with the literature, it's variable as a borderline, and then starting with that to check the better one. That's why, those who is efficient with the computer packages, really can do a lot of work. And just keep on trying. Well,
Here's the pairwise correlation with the drop zeros, Professor. So we can see
okay. Uh-huh. Mm. Okay, so MTR is really high here for all of them. Okay. Basically, it started with this VIF criteria, and our author say it's greater than 5, and especially the grados, say 10, greater than 10. So, for our examples, it's never exceeding. Okay. So this is for multicollinearity problem is not that serious. Okay? A lot, right? So it's really running. So now it's 35 seconds. Wow. That's fantastic. That's fantastic. Would you like to be an expert like Dylan? That's businessman. That's businessman. And I really appreciate it. It's really helpful for us in the class to have so varieties, shown in the classroom. That's wonderful. It pays to take this course this semester with these 3, right? Well, I hope I'll teach what you like to expect to learn. Okay. Wow. Oh. Okay. Okay. Mm-hmm. 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 Mm. 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 Mm-hmm. 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 Okay. Mm-hmm. Yeah. Okay. And again, I just mentioned that we need to have the borderline, those variables as a borderline to start with. Okay. So if we do, especially for the science, as long as it is correct, and if it is not significant, I think we still can suffer. We still can live it. Okay, and therefore, if the MTR really caused the problems, maybe we'll drop MTR because the marginal tax rate may not that significant. Important factors to immediately, affect the woman's working hour. But I'm sure education is really matters. Yeah, okay. Yeah, okay. Mhm. 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 Yeah. Okay. Okay. Mhm. Mhm. Yeah. So this one just indicated that if you change the observation, uh, then it may cause multicollinearity. And for this example, actually, if you're working with the whole, look at the whole models and also individual variables, the whole model is not significant. It means that individual it really doesn't really mean their multicollinearity for the set one. Even with either one of x variable is not significant because the whole model is not significant. So the important factors for this problem is change the values can cause multicollinearity problem. Okay, thank you very much. All right. Well, the rest of three, who want to be the next? All right, then, so is J? Okay, I'll do this down. Okay, this is yours. You can do the presentation here. Is this one maybe? Yeah.
Hello.
Yeah.
Hello.
Yeah.
Okay. Oh,
Okay.
it's
Okay.
okay.
Sure.
Now, so I just did the same.
Well,
Okay, so for the first one, I run the regression model using Gretel. And then,
oh, you're using Gradle.
yeah.
Okay. You like Gradles?
No, I just wanted to try.
Okay. I'm gonna try. Okay.
Yeah.
All right.
Okay, so for the findings, I will focus first on the sign of the coefficient.
Mhm.
So for the women's age, so here as the age increases, the R's work in 1975 decreases, vice versa. So there is an inverse relationship with the latter. So maybe it means that the older the woman, the fewer the hours she spends on working.
So, by the way, are you working with whole data or
Ah,
the
same
hours?
as them.
Huh?
Whole data.
Whole data. Okay.
Yeah.
Okay. Sure. Sure. Sure.
And then for the years of schooling, instead of positive, I got a negative coefficient. So it is different from the resulted value. So as the years of studying increases, this is our result. The working hours decreases. So there is also an inverse relationship with the latter. So where the higher or the more time the person spend on studying, the lesser time he or she has to work. And then for the actual labor market experience, we got the same coefficient, same sign. And also for the family income. And then for the father's years of schooling, the expected sign is also different from the resulted value. And then, so as the years of studying increases, the working hours decreases. And then, so maybe there is the higher the time the person spends on studying, the lesser the time he, oh, his child has to work. And then for the husband is age, a little bit bigger. Here. Okay. For the husband's age, we got the same sign. And also for, I don't know, there's no sign in the husband's year of schooling on the table. Yeah, I didn't see husbands. Yeah, I don't have any sign here. Yeah, doesn't have. Where am I? Okay, here. And then for the hours worked by the husband, the expected sign and then the resulted sign is also the same. And then for the husband's hourly wage, it's also the same. And for the number of kids between ages and 6 and 18, also the same. And also for the number of kids under the age of 6. And then also for the mother's years of schooling. And for the federal marginal tax rate facing a woman, this one is really suspicious. So, but it got the same sign. And for the interpretation, maybe as the federal marginal tax rate increases, the hours working decreases. So there is an inverse relationship with the latter. So maybe it's because if we lower the marginal tax rate, it increases the after-tax income, which can motivate a person to work more hours. And then for the unemployment rate in country of residence, the expected sign and the resulted sign were the same, and it has an inverse relationship. So maybe when the number of unemployed people declines, companies may find it more difficult to locate trained and qualified personnel, which could result in an increase in working hours. So maybe that is the reason behind this one. And then we don't have expected sign for the estimated wage. And then for the p-value of the explanatory variables, education, father's education, husband's age, husband's education, mother's education, and unemployment, it is higher than 5%, which is normally the threshold of significance. I just saw that on the internet. And then this may or may not mean that the alternative hypothesis is true if that null hypothesis is rejected. And then,
I like to mention that the p-values, again, I think I did it,
yeah.
okay? But the p-value, always remember that from the computer output is two-sided test. Always remember that. So if you want to whether see the significance or not, you have to divide it by 2. If it is both sides, never
Yeah.
mind. Okay.
Okay.
Always remember that. I think we easy for us to forget. Okay, just I like to mention it.
Okay.
Okay, sure.
And then for the expected signs, the summary is the age, education, father's education, husband's education were different from the resulted sign. And the number 4, run and explain the pairwise correlations among explanatory variables. So from this heat map, we can see that the brightest red is the correlation between the husband's age and the wage, which has 0.89. It has a high positive correlation coefficient. And then we can see here in MTR and family income, we have a high negative correlation coefficient of negative 0.88, followed by negative 0.72, which is a correlation of MTR and husband's wage. And for the other one, other positive, highly positive correlation coefficient, it is the husband's wage and the family income. So we can see here that this variables, may lead to multicollinearity, which can affect the accuracy and reliability of the regression model. So maybe we can check this 4. So this is the summary, the husband's age, wife's age, and the others, and then these are their correlation coefficients. And then, so for letter B, run and explain partial correlation coefficients. I have run it using this one, and I have focused on this 1, 2, 3, 4. This 4, and it can be seen that and then the covariate here is ours, only ours. We can be seen that the coefficient is high, as expected. And then for letter C, run and explain auxiliary regressions. Oh, I've used EViews here. So long, it's so hard. I have to click many, many times. Yeah. And then, yeah, so I just investigated the same features here, the husband's age, wife's age, MTR, because these are already my suspects. Yeah.
So we run the auxiliary regression.
Yeah.
Okay, using one of the x variable,
Using.
the rest of the.
Yes, yes, yes.
So, did you run this one with only this one
No,
or
no,
the
no,
rest
with
of
the
them?
rest of
Okay,
it.
so this everything, etc.
Yeah, and then I just highlighted
Then
this one.
this is the
Correlation
positive sign,
Mm-hmm.
but you should have this r square.
Oh, yeah, it's here.
Is r square.
Everything is there. Yeah, so many.
Okay.
That's why I just made it in a table. Put it in a
Okay,
table.
made a table, but you have to have r square
Oh, okay.
instead of just if you put r square, there's just no signs.
Oh.
It's r square. It's all positive.
Okay, so R squared.
You see what I'm saying here?
Mm-hmm.
Not correlation coefficient. When
Oh.
we do the auxiliary regression,
We
we
have
wanted to know the r square
Oh, okay.
instead of the correlation coefficient.
Oh, okay.
Okay?
Okay. I
The
got it.
auxiliary regression is
Mhm.
the r square.
Okay.
So you don't have to put the sign here.
Oh,
But it's
okay.
all positive.
So
look at-
for auxiliary.
How come this is a negative?
I just took individually from the result. Like
You
from
mean
the
this
first
one with
OLS.
this one?
Yeah.
But
N-
when
no.
we say, this is what I'm saying, that
Wait.
explanatory variable. Let me see all this one. Okay, this is the one you run, right? Like the excuse me.
Okay.
Like
here.
this one, the father's education as a
Yeah.
dependent variable. The
Mhm.
rest of x, and here is the r square.
Oh yeah.
But we don't have correlation coefficient here. But how did you get that correlation
I
coefficient?
check on this one.
How can you
Yeah.
check with this one? There's so many different signs.
Yeah.
So we wanted just r square only.
Okay, only R squared.
Only r squared, and r
Okay.
squared is always positive.
Mm-hmm.
Okay, so show this one.
Okay.
Okay,
So for
and the higher means this some variables like this father's education with those regresses relationship is 39%.
Okay.
Oh, all right.
Okay, so for auxiliary regression, we have to focus on R squared.
Yes.
Oh, okay.
Yes. Do not post just the r square, just r
Okay,
square.
Okay.
All right.
Oh, okay, I got it.
Okay.
Where- And then for our VIF.
VIF.
So here we got MTR with the highest VIF, and then followed by family income, the aid, and the age. So these three have a high chance that these three are the cause for multicollinearity, and then suggest a remedy to deal with the multicollinearity problem. So by checking the VIF, I tried removing MTR first because it has the highest. And then
Okay, you're removing MTR and check the
Yeah.
VIF.
yeah, so the VIF of the other explanatory variables got lower, but still age is higher than 5.
Oh.
So I tried to remove age, and then when I remove age, all are lesser than 5.
Okay.
Yeah.
This is what I wanted to say, that if we check in all this output and do some modification, is what we say fission. Fission. We don't want to do the fission. We should have borderline to start with. And the borderline is according to the literature review. So those variables, you just couldn't move. You couldn't move it out, like age, education, experience, and kids less than 6 years old. I think this 4 at least,
Yeah, has to be removed.
and you really couldn't move it out. Okay, you should have this 4 to start with. Let me see, any hours? Anything else?
Yeah, only those two.
Education, experience, age, education, experience, and I think family income too, okay, and kids less than ours, less than 6 years old, and unemployment rate and MTR. Yes. You mean hours? Oh,
Oh.
the variable hours. No. We shouldn't do that.
I just,
Yeah, we shouldn't do that because hours is our dependent variable.
variable.
So you're unable to do this one. Okay.
Yeah,
All right.
should have removed that one. Okay.
Okay.
Yeah.
This again, multicollinearity is the problem with all x variable only. I think this is important. These problems all associated with the relationship with x variable only. Nothing to do with the y variable. We wanted to do, they are all highly correlated with the y. That's why we say we have the important factors. But if the x variables were highly correlated, that's cause problem. So multicollinearity only occurs among x variables only.
Yes. Oh yeah, this one should be removed. Okay. And then for the regression, I remove the MTR because I remove it in the VIF.
Okay, sure.
And then, but the sign for education is still negative. It has to be positive. So I tried to remove MTR and family income, but the sign now is not positive for education, and all are the same. But the R squared is very low. It's 0.34.
Okay,
Yeah.
again, r square, whether it's lower or higher,
It's okay.
it's not okay. It's because of it's because of the different discipline. I mean,
Yeah.
from all of you, all the data is from laboratory. Okay, then you should have high r square. You should have high r square, and those observations from business, from education, from psychology, that's all related to human behavior. And all this data is really occurs not from the laboratory. So we do have so-called lower R square. So if you have something like 15%, 30%, maybe it's good enough.
Okay.
But for the lab, no. And usually for the time series data, relationship should higher than cross-sectional data, because it is time series. As long as they have some relationship with the times, then it should have higher R square.
Okay.
Okay.
Yeah, and then I tried to remove this 4 because this 4 were quite suspicious from the previous correlation
Okay.
analysis.
Okay.
And then the R squared is still this one. Same, lower.
Okay.
Yeah, I just tried those things.
Yeah, sure.
Yeah,
Okay.
so to address this multicollinearity problem, the features might be selected or transformed. So for us, we just selected the features to be included and then just remove some features that we think are suspicious, but we are not sure. Yeah. And then for number 2,
Okay, I think that'll be
yeah, it's
enough. Okay,
I think
I'll
so.
read it by myself, and
Mm.
we still have 2. Which one to be the next one? We have 10 minutes only. I think we have some students from, they are coming for the class for 12 o'clock, so we should leave here on time. Okay, so Rachel will be the next. All right. So here, downloaded. Okay. Just do the question 1. Okay. Okay. The rest of them I'll read it by myself.
Okay, so I will just skip this part and go to the regression. At first, I are running the sample of 753 samples, and then Steve remind me to do the condition with hours greater than 0. So I
Okay.
will just compare these two.
All right.
Yeah, we have some different sign over here. For mother education, before it was positive, and then it turned out to be negative in this
Okay.
side.
Can we make a little bit larger? Is it possible to make it? Yeah, okay, sure. Okay, sure, thank you.
Okay, and then the adjusted R square also reduced from the whole sample into the condition. And then if I also put the Gretel here, it's also more convenience for us to see the significant variables or not.
Okay.
The more star is the more significant here.
Yes.
And then this is the equations. The regression has quite significantly R square of 0.31, but there's a possibility that each explanatory variable is insignificant. As seen on the table, if the number of p-value greater than level alpha, which is 0.05, means that the variable is insignificant. And it might be because of the collinearity between the independent variables. And so we need to test whether the collinearity or not. And this, the pairwise. For the pairwise, I use the whole sample. I forget to change it into the one with conditions, but I found the age with husband age is quite high, and then the family income with husband wage, this one is also quite high, and the other one is MTR with family income. This one it have negative correlation. And then so we have 15 explanatory variables. That means we have 105 pairwise, and it's just the explanation of the sign. If it possible, if it positive, it have perfectly positively correlated. And then the correlation between age and husband age is a 0.888. Between family income and husband wage is 0.725, and father education and mother education is 0.573, which, and between marginal tax and family income is 0.88. These 4 are is high, is absolutely value. Then we know that these two particular variables are quite correlated between each other, and either positive or negative. So I will skip the partial correlations. And this is the auxiliary regressions. I also, it's to be put the whole sample with the condition that hours greater than 0 to compare these two. And then this is the equations, and we have it's supposed to be R square like professor said, but I forget to, because I always remember about the adjusted R square, so I put it wrongly here. But yeah, this one. Okay, just skip the auxiliary and goes to the summary. Okay, there's a lot of auxiliary here. And then, yeah, if I could say that the high the highest, yeah, the VIF, the highest, um what is that, oh, the highest R square of the auxiliary is age, family income, husband age, husband wage, and also MTR. So I suspect about those variables, and also the father education and also mother education, because the two variable have to have highly correlated that will be impact the other X variables. And I got this VIF here, and the highest one is age, family income, and husband wage, but not really that much. So yeah, this is the formula that match with this table. And then for the remedial, I strongly recommend dropping the redundant variables. If we turn to the correlation on pairwise correlation, we can simply identify that wife age has strongly correlated to husband age, and family income with husband wage. We could drop father education, husband age, husband education, mother education, and kids greater than 6. Why kids greater than 6? Because it has insignificant p-value on the original model that I shown in the first beginning. And for father education and mother education, because it has a strongly correlation between each other, and it might affect the others variables. And for husband age, because it have the p-value also insignificant. And for husband education, wait, oh, because it's also shown the insignificant p-value at the first beginning, so the revised model is shown. And also, and at the beginning of the regression, it's shown that education and unemployment rate is also insignificant, but I decide to keep the education because based on the literature review, the education is quite important to the models. And I got this result if I drop these 5 variables. But as we see, the education and unemployment rate, it's quite insignificant, so I'm trying to revise with unemployment again, and it turned out like that.
By myself, and we don't have time for John, but you will be the first one for next assignments, okay? All right? Since we don't have enough time for all of you, but you will be remember, you will be the first one for next assignments, okay? And which, I try to finish, have a seat, okay? I try to finish the heteroscedasticity next week. Then the following week, we will have assignments due. Okay, this is the schedule. Okay, all right. So that's for today. Okay, is that interesting? For this assignment, is interesting? It's challenging. It's pretty challenging. I know that. Okay. But I think this should be the graduate school work. Okay? All right? Then, thank you for everyone. That's for today. Oh, you have done this one? Okay, sure. Thank you very much.
Maybe I can send, I'll just make my report video, Professor, the code one, and you can run my assignment.
Yeah, sure.
Because I can also put